Hi everyone, in this video we will learn how to use SigmaXL to perform a chi-square test. A chi-square test of association. And what is an association test? It's a hypothesis test that determines if two categorical variables are statistically independent or if there is a significant relationship between them. Let's explore what some of these phrases mean. Let's explore the first one first. Categorical variables. What are categorical variables? Data that sorts people or things into distinct groups or categories. So think of car brands, Toyota, BMW, Ford, Honda. That would be an example of a categorical variable. Job satisfaction, satisfied, neutral, dissatisfied. Marketing channels, email, social media, print advertisements, word of mouth. These are all examples of categorical variables. Lean Six Sigma practitioners often call this count data. That's because we count how many fall into each category, but we don't really add them up. We don't calculate averages or standard deviation. The next phrase to look at is statistically independent. What does that mean? It means that knowing information about one variable will give you no useful information about predicting the other variable. And then let's look at a related concept called relationship. What relationship means is that the pattern in one variable changes depending on the category of the other variable. So as an example, different age groups might show different preference patterns. Let's explore what the null and the alternative hypothesis for this test is. The null hypothesis is that there is no association between the two categorical variables. That means that they are independent. The alternative hypothesis is that there is an association, meaning to say that the categorical variables are related. It's for chi-square test of association, it's useful to think of one variable as the grouping variable and the other one as the outcome variable. Now let's see how to use this concept of grouping variable and outcome variable. Here is an example. There's a pizza chain that wants to determine if there is a relationship between customer age group and preferred pizza type. So in this example, the grouping variable becomes the customer age group. So there are Gen Zs, there are millennials, and there are boomers. This is the grouping variable. The outcome variable will be the different types of pizza: pepperoni, Hawaiian, meat lovers, farmers, and so on. In the next example, which we will do in Excel, is that of a training provider. For this training provider, there are two types of training methods: classroom and online, and those become the grouping variable. The outcome variable will be the performance based on this training method: high, medium, low. Now let's look at Excel and let's see how we can do this test here. So the training provider has data from about 80 trainees. There is method, there is performance. Performance has been categorized as high, medium, or low. The null hypothesis is that the training method and performance are independent. There is no association. And the alternative hypothesis is that training method and performance are associated. To set this test up, we would need to have a cross tabulation table, which is very easy to do using Excel's pivot feature. So the easy way to select all of this data is Control-Shift-8, and the shortcut for pivots is Alt-P, and then you press finish. So there, a pivot table has been generated. Drag method to rows, performance to columns, and performance once again to values. I like to go to design and report layout and show in tabular form. I like to do that. It makes the data cleaner. Now once we have this, what we need to do is select the two rows, classroom and online, and the three columns, high, low, medium. So let's select them like this. Go to SigmaXL, statistical tools all the way to chi-square tests, and we need to select the third one, the one that says chi-square test in association two-way table data. Once we click on this, we get a dialog box. In the dialog box, the selection that we made has already been captured. The confidence level is at 95%. That's the default. That's the most commonly used confidence level in business settings. It's asking us to make one selection here for nominal categories and ordinal categories. Now, what are these nominal and ordinal categories? Ordinal categories have meaningful order: high, medium, low, good, better, best, fair, good, excellent. So whenever you have order in your categories, you will choose ordinal. Remember, order, ordinal. Nominal categories are those that have no meaningful order. So in this example, for example, if we had cities instead of performance, say the training performance in New York versus Chicago versus Miami versus San Francisco, then we would have chosen nominal categories. The moment we click next, we will have our data ready. So let's do that. Let's click next and view the output. All right, so SigmaXL has generated a lot of data for us. The two things that we are going to focus on are the chi-square calculated value and the p-value. So let's look at these first. So the chi-square calculated value is 3.818. I have a chi-square table here for you. And what we are going to do in this table is we're going to look at 2 degrees of freedom and 0.05 level of significance. And why are we looking at 2 degrees of freedom? The formula for degrees of freedom is rows minus 1 into columns minus 1. So remember, there were 2 rows and there were 3 columns. So that's 2 minus 1 into 3 minus 1, that's 1 into 2. So we're looking at 2 degrees of freedom. And at this intersection, I've highlighted for you the value of 5.991. Now, our calculated value of 3.818 is less than 5.9. So we fail to reject the null hypothesis that training method and performance are independent. We will come to the same conclusion using the p-value as well, in this case, the p-value is 0.1482, which is more than 0.05, again, meaning that we will fail to reject the null hypothesis. In other words, we don't have sufficient statistical evidence to say that the null hypothesis is incorrect. Based on these results, what can we conclude? We can conclude that there's no statistically significant difference in performance outcomes between online and classroom training methods. Why does it matter? It matters because now this training provider can make a decision to switch completely to online training, assuming it is the more cost-effective method, and they can focus on content quality rather than on training format. Hope you found this video useful. Thank you for watching.